Today, we are going to just start to do the 2021 midterm mid-year revision, right? So we actually pressing pause on going forward with the curriculum just for like maybe a week, right? Where we could just do a review of everything we did from September coming straight up the line to now. And the best way to do a review is to do questions. So I gave you guys some questions to do. And I know that you all probably wouldn't have done it because I know it's exam time now and all that kind of thing, right? But at least you all are here to see how it is done and to understand how it is done, and you'll have the video on how it is done. So when is your time to get to it? So you can see that we start off here with a kind of weird looking question, right? And Shazay, since you didn't do it and you are the only exam student in the class, you're gonna be the star of the show today, right? So Shazay, how do you think we should tackle this question here? What should I do first? When you have multiple things being added and multiplied and divided, is there some rule or law that we should think about?
BODMAS.
Yes, and what does BODMAS say we have to do first? People that say BODMAS, right? People that say BOMDAS, right? BOMDAS is definitely funnier, yeah? But what I want you guys to keep in your mind, remember how from the very first class, way back when, yeah? I was telling earlier how we have 4 operations in maths: addition, subtraction, multiplication, and division, right? But what is, let's take addition and subtraction. Subtraction is just addition in the other direction. Subtraction is just you're adding a negative number, right? So addition and subtraction is really the same thing. It's just addition. Right? Subtraction is when you add a negative number. When you have multiplication and division, what are you doing? What is division? When you divide by 2, 5 divided by 2, you're actually just multiplying 5 by a half. Yeah? So division is actually just multiplying by a fraction. Yeah? So really and truly, multiplication and division is the same thing. Right? So really, instead of having 4, we had addition, subtraction, multiplication, and division. We see that addition and subtraction is basically just addition. We see that multiplication and division is just basically multiplication. Right? And a way to think about it like that, multiplication and division, you could think about them as being the same thing. Addition and subtraction, you could think about them as being the same thing. Yeah? So it's really just 3 areas that you are looking at. You're looking at brackets, number 1, right? You're looking at multiplication, number 2, and you're looking at addition, number 3, right? And if you really want to get very philosophical with it, right? We thought that we had 4 operations in maths, but we see that we really only have 2. But guess what? And when you multiply 6 multiplied by 2, that is just you taking 6 and adding it twice, right? So really and truly, addition and multiplication is the same thing, right? Multiplication is just repeated addition. So really and truly, in all of maths, this is the only operation that we just use, Yeah? Believe it or not. Yeah? Believe it or not, right? So, but let me not digress. When you're thinking about BODMAS or BOMDAS, don't think about division and then multiplication. Think about them as the same thing, multiplication. And addition and subtraction, think about them as the same thing, right? Addition, right? So we can see here that I definitely had to handle the multiplication first, yeah? And Shazay, you're okay with what this bodmas bomb-ass thing, right?
Yes.
Alright, I hope Caitlin and them okay with it too, right? So we're just taking the multiplication first, so that's 2 minus a quarter plus the multiplication, which is a half times a quarter. How do you multiply two fractions? You multiply your numerators, you multiply your denominators. So that is 1 times 1 is 1, and 4 times 2, 4 2s are 8. Nice. Now we have this, which is addition and subtraction. So we can actually just do any one. So let's just take 2 minus a quarter. 2 minus a quarter is what? 1 3/4 plus 1 over 8. Right? Let me just say 4 1s are 4, 5, 6, 7. 7 on 4 plus 1 over 8. Right? How could we add these two fractions now? Anybody?
Then to the meters.
Right. Now, listen what she say there, right? But I don't want you to think about that LCM nonsense at all. Because that LCM thing could confuse you. I just want you to think about this one procedure. And that is, you multiply your denominators. So 4 8s are 32. But I'm not going to put 32. I'm going to put 4 times 8. Yeah? Then, you cross multiply. So 7, 8 times 7. So I'll put that on this side. 8 times 7. And then you cross multiply 4 times 1. So plus 4 times 1. Yeah? So good job, Caitlin, with remembering that. Right? And now we'll have 7 8s 56 plus 4 all over 4 8s 32, which is 56 plus 4 is what? 60 all over 32. And anybody could give me 60. Calculator lady, you might have to shine today. 60 over 32.
1 and 7 over 8.
1 and 7 over 8. Yes, actually, yes. So 1 and 7 over 8. So it didn't end up being 4. Okay. So at the end of the day, just remember this procedure. You multiply your two denominators, right? And then you cross multiply like this. The 7 times 8 gonna go on this side with the 7. So the 7 staying on this side where it is, and the 1 going to be staying on this side where it is. So 1 times 4. So we see in here that I have 4 over 2 minus a half in brackets. Now these brackets are written wrong, eh? Yeah? It's supposed to have this outside bracket to match this outside bracket here. Yeah? So that you could see that this 4 over 2 is inside of brackets of its own, and that is inside of these bigger brackets here. And that is a correct way to do it. So wherever I got this question from, they wrote it wrong, right? Sorry, 1 over 2 inside of this bracket here, plus 1 times a half. So yes, Shazay, you do inside, and we'll do inside the very small bracket first. 4 over 2 minus 1 over 2 is 3 over 2. So now I have 3 over 2 plus 1 times a half. Right? 3 over 2 plus 1. Shazay, where's an easy way to do 3 over 2 plus 1? Yeah, you could change the fraction to 1.5. So that is one way you could do it, right? If we have 3 over 2 plus 1, she's saying one way we could do it is to change this to a mixed number. So that is 1.5 plus 1, which we could see is 2.5, right? But there is another way to do it, and we could actually take this 1, right? And we could say, well, 3 on 2, and guess what? 1 is really 2 on 2. Yeah? 2 over 2 is 1. Yeah? So we could actually have 2 over 2, And because they have the same denominator, means that we could just add the numerators. 3 and 2 is 5 on 2, which is 2.5. Yeah. So we end up get here 5 on 2 in the brackets being multiplied by a half. And when you're multiplying fractions now, your numerators and your denominator, so that's 5 on 4 is the answer. We have some indices here, and this was a bit of a revision on the laws of indices, right? So if we remember our laws of indices, you remember that when you if you have the same number and you multiply the same number, what do you do to the indices? Anybody?
Add them.
Right. So you're adding them. So 6 plus what will give me 70?
11.
Very good. So this is 11. 6 plus 11 is 7. When you're dividing indices, what do you do?
Minus them.
Right? So 6 minus what will give me 4?
2.
Thank you. When you have this weird situation here, where you have an indice and then brackets and an indice outside of that, what do you do with the indices?
Multiply.
Multiply. Excellent, Shazzy. You remember in this one. So 19 times what will give me 95?
5.
Yes. 95 divided by 5 is 90. Yes. So 5 over here. Right? And this is the same situation over here. We could see 8 times what? Oh, and by the way, because when you multiply, you just get that, that would mean that a to the power of 19 all to the power of 5 is the same as a to the power of 5 all to the power of 19. Yeah, these two are actually the same because you just multiply your indices and you'll get the same number. So that's a nice little thing to keep note of there. And all of these things, we learn all of these things just to do algebra. You know? So 5 times 8 will give me 40. Right, so we're talking about some standard form here now, right? So convert from decimal to standard form and vice versa. So I have a decimal here. I want 4.0 by 10, and now I have to decide what number to put up here. So I'm gonna go 1, 2, 3, 4. So by 10 to the 4, but it's going to be negative 4, right? Shazay, you understand why it would be negative 4? Right, because from here, in order to get from this 4 to this answer, you'll have to go backwards, eh?
Yes, sir.
Right, so because you had to go backwards, means it'll be negative 4, and then you will end up with this answer, yeah? If I had positive 4, 4.0 by 10 to the positive 4, I would have to go this way. Right? So then I will have 4, 1, 2, 3, 4. That is 40,000 would be the answer. Right? Which makes sense. Yeah? So if you want to get to a decimal, negative. If you want to get to a big number, positive. So you can see here that all of these guys are going to be negative. Right? Because so with this one here, I'll put it as 1.42. Remember, I'm not going to use 14.2 because the number that you use must be between 1 and 10. So 1.42 by 10 to the, and I just had to go back 1, so it's negative 1 to give me this answer here. Right? Yeah, so this one here is 1.9 by 10 to the, and if the point was here, 1, 2, 3. Alright, so that is negative 3. And 1.9 by 10 to the negative 3. And then over here we have 9.7 by 10 to the 1, 2, 3, 4, 5, 6. Negative 6. When it comes to these questions over here, you just move the point, positive direction, so positive direction, 1, 2, 3, 4. So that's 36,000. So this is 1, 2, 3, 4, 16,000. And then this is 1, 2, 3, 4, 5, 6. So that is what? This one, 1, 2, 3, 4, 5, 6, 4. So that is 1,250,000. Ah! Algebra here now, man. Very cool. Make X the subject of the formula. So we're reaching some algebra here. But we just want to end up with X alone on this side. So we need to get rid of everything else. We don't want to add anything else, right? So what she said first is to take this negative t. We want to start far away from the X and work our way closer and closer. So we take in negative t and we flinging it across. So now dx is equal to 8 plus t. Shizzy, Shizzy. Hey Shizzy, you mind if I call you Shizzy? Yeah? Okay. But Shizzy, you understand what we did there?
Yes, sir.
Alright, you sure, right?
Yeah.
So you can see that you was overthinking. Yeah? And now we got rid of the t, but now we have to get rid of the d. So we see in here that in this side is multiplied by d. So when we fling it across, it's going to be all of this, 8 plus t, all of that divided by d. Alright? So Shazay, you okay with this?
Yes, sir.
Alright. I have a slightly harder one here to make x the subject of the formula, right? S is equal to x squared minus 3. And I want to make x the subject of the formula, right? So how am I going to make x the subject of the formula now?
I rewrote it first.
Very good. You write it out. X squared minus 3 is equal to s. Is that what you did?
Yeah.
All she did there was we flip it. We flip the equal sign, right? So that we can have x on this side, right? Now what?
I brought it across and negative to make it positive.
Alright, so we're starting to clear away things from the x. So I'm throwing across the negative 3 here. So it'll be x squared is equal to s plus 3. And now what?
I threw over this square to make it square root of s plus 3.
Very good, because when you throw over a square, you make a square root, because 5 squared is 25, eh? So therefore, if we get rid of the square, 5 alone will be the square root of 25. Make sense, Shizzy?
Yes, sir.
Right? So hence, if we want to get rid of the square, x alone will be the square root of s plus 3. Nice. So all of these things, all of these questions I selected just so that I could remind you guys of all of these things we have here. And Shazay, try this one. X over 6 minus 5 is equal to w. Make x the subject of the formula, Shazay.
25 on the next side and make it plus 5.
Very good. W plus 5, and what now?
Take the 6 and make it multiply. Yeah.
Yes.
On the next side and multiply by 6.
Yes, because on this side it's divided by 6. So when you fling it across, all of this, w plus 5, is going to be multiplied by 6. Alright? Good job, Shazay. Shazay, you want to try your hand at this last one here? X squared plus a is equal to v. Make x the subject of the formula.
Flip the a on the next side and make it negative a.
V minus a, yeah.
And then put it the square and make it the square root on the next side.
Very good. V minus a, right? The square root of everything. Now this root thing does work for anything, right? So if it wasn't squared, if it was cubed, right? Then I could say x is equal to the cube root of v minus a. Yeah? If it was to the power of 5, I could say x is equal to the 5th root of v to the minus e. Right? Thankfully, in CSEC, you may not have to do anything like that, but it's always good to have the understanding, right? So good job with the, oh no, we reached some really tough stuff here. Everybody hates the worded questions. All right, so what you're saying is that I have 3 numbers, right? And I add in these 3 numbers to give me negative 126. That's what you're saying.
Yes, sir.
Right. And the next thing you're saying is that these 3 numbers are consecutive, eh?
Yes, sir.
What do you know about consecutive numbers? Like 25, 26, 27. Them is consecutive numbers, eh?
Yes, sir.
Alright, 105, 101, 102, 103. Them is consecutive numbers, eh?
Yes, sir.
What do you know, what do you notice about consecutive numbers?
Become my chapter.
Right. Right. So what does it mean that this first one here, what do I have to do to this first one to get the second one?
You add 1.
Right. And what do I have to do to this one to get the next one?
You add 1.
Right. So imagine I have 3 consecutive numbers, but I don't know what they are. Right? So I'll call the first one x. Right? Plus, wouldn't the second, what do you think the next consecutive number after x will be?
1? No.
Make sense?
Yeah.
Yeah? And what do you think this next one gonna be?
X plus 1.
Careful.
X
Like,
plus 2.
yeah, it's x plus 2. And think about it, right? If it is that I had 5, right? 5 plus 1 is 6, right? And I would have to take this 6 and add it to 1 to give me 7, eh? Yeah?
Yes.
So 5 plus 1 is 6. And I would have to take this 6 plus 1 to give me 7, right? So how can I think about that, right? X plus 1 will give me x plus 1, right? And then x plus 1 plus 1. And
Yes, sir.
will give me x plus 2. Make sense?
Yes, sir.
So these questions is not a maths questions, you know. These questions are understanding questions, right? You really need to be able to analyze. So we have here minus 126, and now we just simplify. So x plus x plus x, I could remove the brackets because I don't have nothing being multiplied or divided or anything. So I'll end up having 3x, and then 1 plus 2 is 3. So 3x plus 3 is minus 126. 3x is equal to negative 126 minus 3. So 3x is equal 6, 7, 8, 9, negative 129. X is equal to negative 129 divided by 3 to negative 43. Yeah? So the first number is negative 43 plus the second number is negative 43 plus 1, which is negative 42. And the third number is negative 43, which is x. X is negative 43. So that's x is negative. And negative 43 plus 2 is negative 41. And we have the 3 consecutive numbers there. Is the exact same thing that we did before. They say find 3 consecutive integers. So you know 3 consecutive integers, we just had it there, x plus, well we don't know about x, we don't know about plus anything yet, right? But 3 consecutive integers, the first one will be x, the next one is x plus 1, and the next one is x plus 2. Those are 3 consecutive integers, right? such that the sum of the first, so I'm taking the first and I'm adding it, the sum, twice the second, so the second number being multiplied by 2, and 3 times the third, so I'm adding the third one multiplied by 3, and I'm getting the answer of negative 76. You had to find what are the 3 consecutive numbers. So let's find, let's just expand everything out, right? So we'll get x plus 2x plus 1, 2x plus 2 plus 3x plus 3 2s are 6 is equal to negative 76. Let me add all of my x's. So x plus 2x plus 3x. 3 and 2 is 5 and 1 is 6. That is 6x. And then 6 plus 2 is 8. And that is 76. Negative 76. 6x is equal to negative 76 minus 8. I throw the 8 across. So 6x is equal to negative 84. X is now negative 84 divided by 6, which is negative 14. So we know the first number is negative 14. The second number is negative 14 plus 1, right? Which is negative 13. And the third number is negative 14 plus 2, which is negative 12. Okay? And those are the 3 consecutive numbers. So we have solved the equation here, and at the end of the day, this is just more of the same stuff we've been doing all the time. So first we have 5 plus n over 4 is equal to 4. We had to solve for n, so I'll fling across the 5. So n over 4 is equal to 4 minus 5. N over 4 is equal to negative 1. And now I'll fling across the 4. So n is equal to negative 1 multiplied by 4, which is negative 4. So that is the first one. And I hope that that was cool for everybody. If I'm going too fast, just let me know, right? The second one is 102 is equal to negative 7r plus 4. And I'll just flip it around. Negative 7r plus 4 is equal to 102. I'll just throw the 4 across. Negative 7r is equal to 102 minus 4. Negative 7r is equal to 102 minus 4 is 98. 98. R is equal to 98 divided by negative 7, which is negative 14. So Shazay, you understand all this stuff pretty easy, right?
Yes, sir.
You're sure? That will sound like a pretty convincing yes to me, you know?
Yes, sir.
You gotta say yes sir with a smile, you understand?
Yes, sir.
You don't have to say the sir part because it makes me feel old, but you know, you gotta say yeah.
Yeah.
Alright, cool, right? Negative 8n plus 3 is equal to negative 77. So I'll throw the 3 across. Negative 8n is equal to negative 77 minus 3. Remember when the signs are the same, right? Anybody remember those rules? Yeah? When you have the same signs, you just add it and keep the sign, yeah? So negative 8n is equal to 78, 79, 80, negative 80. You add it and you keep the sign, right? So therefore n is equal to negative 80 divided by negative 8, which is the negatives cancel, straight up 10. Right? This one here is just some more laws of indices. So anybody want to try this first one and tell me? When you're multiplying, what do you do to the indices? And remember, the only way laws of indices could work is if the base number is the same number. So the minute you have 2 to the n multiplied by 3 to the 2n, this is not going to work because those base numbers have to be the same, right? So, what is this? What do I do when I'm multiplying? Add the indices, right? So that's 2 to the power of n plus 2n plus 3n. So that is 3 and 2 is 5 and 1 is 6. 2 to the power of 6n. Right? With this one, it is a to the power of 3 plus 5 is 8 minus 2 is 6. Right? And this one, x to the power of 4, 5, 6, 7, 8, 9. Yeah, so you just add the indices. Right? We have some slightly tougher indices questions here now. Yeah. So anybody remember what is a squared brackets 0? What does that work out to? Yes. A to the power of a half all to the power of 4. Now remember what the rule says. The rule says that when you have these bracket things with an indice outside, you multiply the indices, right? So this will be a to the 2 multiplied by 0 is 0, multiplied by a to the a half times 4 is 2. So this is a squared, right? And remember, anything to the power of 0 is 1. So this is 1 by a squared, which is just a squared. So the answer for this is a squared. Shazay, you okay with this?
Yes, sir.
All right. I hope you're writing these things down, right? Shazay, I want to. Oh, this is a tough one. Let me see. Let me see if you guys remember this rule here. 2x brackets to the negative 3 divided by x 3. And what they say here, rewrite the following expressions using only positive integers, indices, sorry. So anybody remember any rule that involved a negative indice? What is that? If I had x to the negative 1, what does this mean? That's just 1?
Divided by x.
1 divided by x to the 1, and excellent. So it seems to me, Shazay, that you forgetting all the SCA stuff, but it have some stuff that you remember in. Yeah, excellent, right? So remember, when you have a negative indice, if I have a to the power of negative 5, that is really 1 all over a to the power of 5. That is what that is. Yeah? So I have this fraction here. Guess what? I could split up this fraction, right? Because, and if I have 2 all over 3, and I could split this up, isn't this the same as 2 over 1 multiplied by 1 over 3? Yeah? Right? So I could split the fraction up just like that, right? I could say 2 to the x all over the negative 3 over 1, right? Multiply by 1 over x to the 3. So I'll split them up like that, right? Shazay, you understand how I split them up, right? So at the end of the day, now I could do the thing where 2x to the power of negative 3 is really 1 over x, 2x cubed, right? Sorry, let me just write that a little bit. I find I write enough it's correct. Right? So 1 over 2x cubed, right? Multiply by 1 over x cubed. We can see here that this is in brackets. Yeah? Is in brackets. That 2x cubed there is in brackets. So we want to get rid of those brackets, right? Remember the rule. If I have a to an indice, and that is in brackets to another indice, I multiply the indices, eh? Yeah? You multiply the indices, right? So we have here 2x to the power of 3 outside. The indice inside here is, this is x to the power of 1. And guess what? This here is 2 to the power of 1. So I have to multiply these indices, this here and this here. Yeah? So what will I get? I will get 1 all over 2 to the power of 3 times x to the power of 3. Right? Multiply by 1 all over x to the power of 3. Yeah? And now we could say, well, let's simplify. 1 all over 2 2s are 4 2s are 8. 8x to the power of 3. Multiply by 1 over x to the power of 3. Now I can do this, and x to the 3 times x to the 3, that is 1 all over 8x. You add your indices to the power of 6. So the answer to this is 1 all over 8x to the power of 6. Yeah? So number 40 is 2a squared b to the power of minus 2 all over 2 to the power of minus 3 b to the power of minus 4. And remember this whole thing about splitting up the fraction. I am going to split up the fraction. And how am I going to split up the fraction? Well, I notice the 2's, I can group the 2's together into one fraction. And the a could be by itself and the b's could be one fraction. So how about if I have, and let me see if you all agree with this. 2 over 2 to the negative 3. So you see I group them 2's there. Multiply by a squared over 1. Multiply by b to the negative 2 over b to the negative 4. You all agree with this? Shazay, you agree with this?
I tried to group them, but I didn't group the a by itself.
Right, you keep the a and the b together.
I keep the a with the 2, and I just do the b's on the
right. No, that is not necessarily. Sorry, what is it?
I said I did the same thing.
Right. Now, what you guys did there, it may not necessarily be wrong. They have many ways to do it. Right? So that may not necessarily be wrong. Now, I have 3 fractions, and you know when you're dividing indices, right? A to the m divided by a to the n is equal to a to the m minus n. The top one minus the underneath one. Right? So, in this case, I have 2 to the, this is 1 m minus the underneath one, which is n, which is negative 3, right? Multiply by, well, a squared, multiply by, same thing, b to the m, which is negative 2, minus n, which is negative 4. Yeah, so what do I have here? 2 to the power of 4, because this is 1 minus 3 is 1 plus 3, which is 4 times a squared times b to the negative 2 minus 4. This is negative 2 plus 4, which is the same as 4 minus 2, which is 2. So this is b squared. So I have here, oh come on, 2 to the m squared n, all to the power of 3, divided by m n cubed, all squared, multiplied by 4m squared, all squared. I will do this one because all you're moving like if all you're vex something, right? So just because I make it all you do work, right? Now the thing is, what I need you to know is this: if you have a to the m brackets n, then you know you had a multiplier indices. That is a to the m n, m multiplied by n. But what if you had a to the m multiplied by b to the p multiplied by c to the r, all to the power of n? Well, you just do the same thing. You multiply the indices. So that'll be a to the mn multiplied by b to the pn multiplied by c to the rn. Yeah? So when you have a lot of things inside of the bracket, you multiply by all of the indices. So this indices is 2, this indice is 1, this, I say an indice, but it's really index, right? And this index is 1, right? So I take the 3, so that'll end up being 2 to the power of 3. M to the 3 times 2 is 6. And 3 times 1, n to the 3. Right? All over. Same thing here. This is m to the power of 1. So 2 times 1 is m squared. And 2 times 3 is n to the 6. Multiply by, guess what? This 4 is to the power of 1. So 2 times 1 is 4 squared. And 2 times 2 is m to the power of 4. I make any mistakes there? Are okay? Right? So now we could try to simplify and all of this kind of thing here. So let's say 2 cubed m6 n cubed all over. Let's handle this denominator, right? So we see m squared multiplied by m4 is m6, and then I already have n6. Alright, so I have these two here being multiplied by 4 squared. 4 squared, if you look at it, what is 4 squared? Isn't 2 squared 4? 2 2s are 4, eh? So I could actually take this 4 and replace it by 2 squared. So 2 squared inside the brackets is 4. Yeah? But now I could take this 2 and multiply it by this 2. So what do I end up with? 2 2s are 4. So this is 2 to the power of 4. Amazing, isn't it? Right? So that is quite incredible. Right? It's all, I hope it makes sense to you guys, right? So what I could say now is, well, this is gonna cancel with this, and 3 of these are gonna cancel with 3 of these, so I'm gonna have n to the 3, right? And 3 of these are gonna cancel with 3 of these, so I'll just have 2 to the power of 1 left. So everything cancel on the top there, so I just have 1 on the top there, and on the bottom I just have 2 to the power of 1 n cubed. Well, let's call this the last question for the night, right? One more question and then we're done. And this question has to do with the topic of, well, you tell me which topic this question has to do with. And this, we actually spent an entire class on this topic alone, and it have an entire video based on this topic alone. Anybody could read this question and tell me what topic it is? So the name of this topic is variation and proportionality. Variation and proportionality. And I'll just give you all like a 2-second review of the topic, right? Let me just say, if your heart rate increases, that means that your blood pressure will increase. You all agree?
Yes, sir.
Right. So when the two of them are going in the same direction, so therefore if your heart rate decreases, your blood pressure will decrease. So when they're going in the same direction, we say this is directly proportional. Right? And how do we say directly proportional? H is directly proportional to B. Right? However, if it is you had a situation where, let me see. If we had volume in a cylinder, if anybody knows how an engine does work. An engine does deal with volume and pressure. And what an engine does do is it will compress the volume. Right? So the gas that goes in, the piston will compress it. And when the piston compresses it to a small volume, the pressure rises. Yeah? So you could see here that they are in opposite directions. When one go down, the other will go up. Yeah? And when one go up, the other will go down. So what we call this is inversely proportional. And we say that V is inversely proportional. That means it's proportional to the inverse of P. Alright? So if you guys remember this topic, and let's just do a question here, this last question, just as a reminder of how this topic does work. And you generally do get one question for CSEC on this topic generally. Yeah? So it's a question. So the electric current, let me call that in amps, right? So let me call that, we could call it anything we want, current, let me call it C. C for current, right? In a circuit varies directly. These two words here, right, is what tells me what topic I'm dealing with. How do I know this is the topic of variation and proportionality? How do I know that this isn't just some normal worded algebra question? How do I know that this is a special topic of variation and proportionality? Because they use these two words. Varies directly. Right? Varies directly as the voltage V. Yeah? So that means that the current C is directly proportional to V. That means that if one goes up, the other goes down. So I make my proportionality statement that C is directly proportional to V. And then I add in my constant of proportionality. So C equals the constant of proportionality, K, times V, where K is a constant. So K is one specific number. You see like how when current goes up, voltage goes up. When current goes down, voltage goes down. So current and voltage, they are variables. They change. But K is a constant. K will not change. K is a special number. So we have to find out now what is the special number that is K. Yeah? How do we do that? Well, maybe the question will help us. Yeah? So what they say here now, when 15 volts are applied, the current is 5 amps. So look, they give me a value for V and they give me a value for C. So they said that when 15 volts, so V is 15, the current is 5 amps. So now 15 is equal to K multiplied by 5. I can actually find what K is. K is now equal to 5 divided by 15, which is a third. So now I have my final equation. I found out what K is. So now my final equation is C is equal to K, which is a third times V. So now I can answer the question. What is the current when 18 volts are applied? So the current is equal to 1/3 when 18 volts are applied. So therefore the current is 6. Soraya, how you feel about this topic? I did this with you when we were in the Form 1 to 3 class. So the Form 1 to 3 class did this topic as well. You remember doing this?
Yeah.
Yes. Right? It's not a particularly hard topic, right? At the end of the day, if you have something directly proportional, then you just add your constant of proportionality. That is all. Right? If you have something inversely proportional, guess what? You do the same thing. You just add your constant of proportionality. That's all. Right? So you just add your constant of proportionality and you should be fine for answering the rest of the question.